The physics of soccer. When a soccer player shoots a soccer ball at the net, he or she kicks the ball off center. This is what causes the ball to spin into the net. The direction and speed of the spin is what determines how much the ball curves when it's kicked. The curve of the ball during its flight is known as the Magnus effect.
When the ball is spinning in the air, friction between the ball and the air causes the air to react to the direction of the spin of the ball. As the ball undergoes top spin, the velocity of the air around the top half of the ball is less than that around the bottom half. This is because the tangential velocity of the ball in the top half acts in the opposite direction of the airflow, and the tangential velocity in the bottom half of the ball acts in the same direction as the airflow. This causes the direction of the airflow to go left relative to the ball.
Since the resultant airspeed around the top half of the ball is less than that around the bottom half of the ball, there is more pressure on top. This causes the net force to act downward on the ball. Bernoulli's principle states that when air velocity decreases, air pressure increases, and vice versa.
So when you kick the ball to the right of the center of the ball spins counterclockwise and the Magnus force acts to the left. This causes the ball to curve left. On the other hand, when the ball is kicked to the left of its center, the ball spins clockwise and the Magnus force acts to the right, causing the ball to curve right.
Next, we went out to the soccer field to figure out how much force a soccer player puts into their kick. In order to find this, we must use Newton's second law. This states that force equals mass times acceleration, and we know that the mass of a size 5 soccer ball is 0.426 kilograms. Now we need to find the acceleration of the ball when it's kicked, which is change in velocity over time. Before the ball is kicked, it has a speed of 0 meters per second, and after it's kicked, its speed is approximately 28 meters per second in about 0.02 seconds. Now we must divide mass times acceleration by 0.02. So we have 0.426 times 28 divided by 0.02 to get 596.4 newtons.
This means a soccer player kicks the ball with 596.4 newtons. To convert this into pounds of force, we know that 1 newton equals approximately 0.225 pounds. Therefore, you multiply 596.4 times 0.225 to get 134.2 pounds of force. That's a lot of force.